In this video, we'll generate the decaying cosine using DeMoivre's formula, using IMPOWER IMREAL complex exponent and Taylor-Maclaurin series sum of Google Sheets and Excel. We begin with the values of V and W. So data validation, list of items from 0 to 0.4. So copy, and this is 0.4. We can start with 0. And the value of W, that is W, so data validation, list of items from 0.6 to 1.4. And we can start with 0.6. Now the data set, which is array formula. The first part is e to the minus vx, so exponent. Minus vx, v times x. That's the first part. The second part, cosine wx, so cosine w times x. And the Taylor series expansion, which is the summation of a times x to the power n, where the value of n is from 0 to infinity. 26 is good enough. And the value of a is the real part of negative VWI raised to the power n over n factorial. So we begin with the complex, so array formula. Complex, that is minus v plus wi, so minus v comma w. That's the first part. And this is raised to the power n. So this will be IMPOWER. IMPOWER raised to the power n. And finally, now that is raised to the power n, we want the real part, so IMREAL. IMREAL, the real coefficient. Now that we have the real part, we can now divide by factorial n. So this will be divided by factorial n. Now we can complete the Taylor series expansion, which is equal to array formula, series sum of the x values raised to the power n, where n starts from 0 incremented by 1, and the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. Column is label. And show the trend line under series, trend line, the type, polynomial. The degree, 8. For the label, use the equation. We don't need a title. So here we have the label and the polynomial, which is the polynomial, and the trend line. Now that we have this, we can change the value w. If we change the value w to 0.6 to 0.8, this is now the value of w. This is the blue one. We have shortened the wavelength. Also, we shortened the wavelength of the expansion. Change it to 1. We change this to, also the red one to 1. Change this to 1.2. Now we have increased the frequency, 1.2. Change it to 1.4. Now we have a higher frequency, also 1.4. So this is the steady state. Let's apply a decay. Let's start with the smaller decay, 0.1. We also apply a smaller decay, 0.1. Now there's a decay. Change the W to 1.2. So we also change it to 1.2. Change this to 1. We also change this to 1. Change it to 0.8. We have a longer wavelength now. Change it to 0.8. Change it to 0.6. Now the wavelength is longer, also 0.6. Now we change the decay to 0.2. We'll also change the decay to 0.2. Change the wavelength to 0.8, W to 0.8. We also change this to 0.8. Change it to 1. We'll change this also to 1. Change this to 1.2. We'll change this also to 1.2. Change it to 1.4. Change this to 1.4. Now change the decay to 0.3. We'll change also to 0.3. Change the wavelength to 1.2. Change it to 1.2. Change it to 1. Change it to 1. Now the wavelength gets longer. To 0.8. Change it to 0.8. Change it to 0.6. Now change it to 0.6. Okay, change the decay to 0.4. We'll also change the decay to 0.4. And change the W to 0.8. So we increase the frequency to 0.8. Change it to 1. We'll change it also to 1. Change this to 1.2. We'll change it to 1.2. Change this to 1.4. And this will catch up to 1.4. So this completes the use of the Taylor-Maclaurin series sum to show the DeMoivre's decaying cosine using the functions IMPOWER, IMREAL, complex, exponent, and the series sum function of Google Sheets and in Excel.